Okay, moving on to example 2, where we're going to start translating between recursive and explicit definitions for geometric sequences. So, on the right side of the screen there in red and green, we have the recursive formula for a geometric and the explicit formula for a geometric. Looks a little different than the arithmetic one, because with the arithmetic we were adding to get from term to term. Now we're multiplying. And as you can see, they're pretty similar, but the explicit formula is a one-stop shop. You don't need the two separate pieces to the formula. Remember, recursive was kind of like a piecewise function where you had to write it out in two statements. The explicit just says, hey, to get to any term in the sequence, an, you take what you start with, and you multiply by that common ratio, n minus 1 times, so that n minus 1 becomes your exponent. All right, so we're going to go from recursive here to explicit for part A. So to get to any term, the 5 is your A1. And then we're going to multiply by the common ratio. And that's the number right here with the A sub n minus 1. So that's going to go right in there, 1/2 to the n minus 1 power. By the way, the book always writes out their recursive definitions a little bit differently than me. Notice how they write the an, and then they do that bracket, right, that brace. I think we did this too back in with the arithmetic sequences. Then you say the number that it starts with, comma, when n is 1. And then the formula to get to the next term, comma, anytime n is greater than 1. It's a perfectly good way to write out your recursive sequence, but I'll also accept it this way, down here in red. Okay, right here. All right, so let's pull this one apart for part B. They give us the explicit, and we're trying to break it up into recursive. Let's go ahead and do it the book's way, because now that I'm thinking about it, I'm pretty sure we did this way back when we learned arithmetic. So we're going to take the number that this sequence begins with, and that's always the number out here in front of the parentheses, 3. So 3 would be the first term, and after the comma, you just say n equals 1. What this is saying is, when this n, right here, is 1, A1 equals 3, because that's your first term. Okay? Then you take 2 times the previous term is always A sub n minus 1, because this R, this common ratio here, is 2. That's going to go right there, excuse me, in front of the A sub n minus 1. And this part of the formula is in play anytime the n is larger than 1. So it's saying when you're on the first term, you use this line. A1 would equal 3. Anytime you get to a term bigger than that, you jump down here and you use that bottom sentence. So you multiply by 2, multiply by 2, multiply by 2. By the way, this first one, part A, if we were writing out the terms, it would start with 5, then it would get cut in half. Then it would get cut in half again, and so on. First term 5, cutting in half. In B, we would start with 3, double it to get 6, double it to get 12, 24, and so on. So if they ever ask you for, you know, the first 3 terms, the first 4 terms, that's what you do. 3 is where it begins. 2 says that's what you're multiplying by. All right, so in the questions that follow, you're going to complete the triads at the bottom here, 2A and 2B, and answer them on this Edpuzzle.